Hey there, folks. Thanks for being here with us today for one of the final, but certainly one of my favorite panels at Datadog Dash. Today, this is our panel on software supply chain, and I'm joined here by some absolutely fantastic guests who I'm going to have introduce themselves. I'm Andrew Krug. I'm security evangelist at Datadog. I'm super excited to be here and talk a little about supply chain. And we'll start the introductions with Trishank just at the top right here.
Sure. Hi, everyone. Pleasure to join you all. An honor. I'm Trishank. I'm an engineering manager here at Datadog. My team is focusing on software supply chain security now. And I've been working in this space for like almost a decade now, which kind of surprised me when I was thinking about it recently. Santiago next, perhaps?
Sure. I am Santiago Torres. I am a assistant professor at Purdue University, and like Trishank, I've been doing research on software supply chain security for maybe a little less than he is, but almost shy of a decade. I pretty much do research on how to produce software security and how to consume software security. It's a seemingly simple problem that has a lot of moving bits and pieces that makes it really nuanced and hard.
And I'll go last. So I'm Asra, and I work at Google on the Google Open Source Security team. And I right now kind of am involved in efforts of supply chain security. So things like projects like SigStore, projects like Salsa. And I am kind of have this background of privacy preserving technologies and cryptography, and kind of moved into the security space as I was like a security engineer on Envoy Proxy, which is an open source project. So having come from kind of like an open source maintainership position in security, I kind of moved into this like general software supply chain security space. So super excited for the panel.
Great. Well, thanks, everybody. I think we're going to have a great discussion here for our guests. Definitely, if you want to ask a question, please definitely do ask a question using the Q&A box in the Dash platform there. I'll also try and keep an eye on the chat as we go through sort of this discussion here. I think that perhaps the best place to start here for those that don't know, since we have a lot of folks who are either new to security or new to supply chain securities, what exactly does this concept mean to you? And it's not even really supply chain security, it's software supply chain security, right? So what does it mean to each of you?
I'll
I could
go
start.
first and just kind of throw out some ideas.
Sorry, Asra, go ahead. My bad.
Yeah. I'll just throw out some like general ideas, and I'm sure Trishank and Santiago will kind of refine my perspective. But like as you kind of are familiar with like general supply chain, it's anything that kind of goes into a product. So like the source of your ingredients, anything that's coming from like the production pipeline all the way up to distribution. So in the software world, it's kind of anything that goes into what's delivered to the customer. So that includes your source code, your CI/CD systems, your dependencies, which is a huge part of everything, all the way into like package managers and repositories that are doing the distribution. So that entire pipeline is what I think of as software supply chain. And then when we think of the security aspects, what I think of is all those places in every single one of those, I think, four things I mentioned, where attackers and just things can go wrong at different stages of things. So I think of software supply chain security as that general pipeline and framework, and security along each of the sort of vectors and places that might be vulnerable to attacks.
Absolutely. Santiago, would you like to build upon that?
Sure. Yeah, and I think Asra touched on like fundamental notions of like software supply chain security, but the way that I like to see it is essentially you having an equation, right? And the right hand side of the equal sign is, well, whatever you're using, like your Chrome browser or like your Datadog deployment or anything really. On the left hand side of your equation, you have all of the things that came to be to make it what it is. Now, attackers can either attack like the arithmetic signs, like the plus signs and the minus signs, or they can attack the individual like polynomials and change them to be something else. And essentially, the reason why I like this metaphor is that it kind of means that there's like more places in which things can go wrong, and the end result will always be different. Otherwise, it wouldn't be an equation. And this is also what surfaces the real danger of supply chain security, right? It is easy to get wrong, and it is very devastating. It does change everything.
I just want to say that I really love that analogy. It's like I haven't really heard it being framed quite like that before, but I really love the whole like, what you get on the right hand side is all a product or something of the left hand side.
Thank you. Yeah, it's also mathematically appealing, so it's good.
Right. Exactly. So I like to call it the y equals f of x problem, right? Do you know what it's 4 a.m. Do you know what your CI/CD is doing? Is it following the equation, right? And that also shows you the how complicated the problem is. There's so many attack vectors. So, and this seems like an insurmountable problem, but actually kind of simplifies your thinking. Now that you know you could get attacked all sorts of ways, I like to define it simply as just a man-in-the-middle attack anywhere between your developers and end users. That's it. And I do generally like to leave third-party packages out of it because it makes the problem more unnecessarily complicated, at least in the beginning. You can't really control your dependencies, what they do ultimately at the end of the day. But the kind of technologies we're going to talk about today, hopefully a few years from now, you can actually wed what they're doing as well. But for now, just to start the problem, you should think about just securing your own supply chain first, and then we can talk about third-party dependencies.
Yeah, and we've seen some fantastic attacks involved software supply chain, especially in the last 2 years. I know that we talk about this presidential executive order that's sort of mandated some sort of minimal sets of controls, but maybe we could just spend a minute sort of breaking down either Flame or Sunburst and how those were kind of interesting and relevant as drivers for some of this technology.
I can go into Flame and I let someone else talk about Sunburst. Does that sound good?
That sounds great. You could start with Flame, Trishank.
Yeah. Flame is one of my favorite attacks, if you could call it that, because it happened in what, 2012, 2013? Somewhere early in the problem where people were still not sort of taking this seriously. But basically the too long didn't read is that it seems to have been a very sophisticated nation state who was determined to peacefully dismantle Iran's nuclear enrichment program. And the way they did it was amazingly clever. They found a way, so Microsoft Windows back then at least, had a peer-to-peer way to distribute updates. And so what they did was find a weakness in the MD5 hashing algorithm that was still used back then. It was, I think, already theoretically suspected to be weak, but no one had found this novel practical attack. Even academics were surprised. Anyway, the point is they managed to forge an update to make it look like it came from Microsoft when it didn't. It slowly spread its way from Europe and all the way to Iran. And the funny thing was that people was like, it's very good at spreading, but it just doesn't seem to be doing anything. That's because what it really was looking for was a Siemens PLC, a particular type of hardware, a particular type of computer. And once it got there, it would very subtly mess with the centrifuges, like once every 10,000 rotations or so. So it took them a while just to figure out what was going on. So yeah, Flame was the first sign that there are very serious people out there with the time and money to poison your software updates and attack millions of people all at once if they wanted to.
Yeah, and I think the nice thing about Flame and Stuxnet is that it also set a precedent of essentially being the first supply chain weapon of war, like software supply chain weapon of war. You can think of it. It's almost like, wow, we're finally at that stage. I can talk a little bit about the Solar Burst, but it's very, very similar in that they essentially found a place like SolarWinds. I think it wouldn't be this. I wouldn't be lying if I said that nobody knew about SolarWinds until like this happened. But it was essentially a third party for the U.S. government and a bunch of different companies that was providing was providing them with a couple of software components. Essentially, what these hackers found out is that they could break into their build system and introduce a little agent that was constantly monitoring compilation processes and mutating the inputs as they were being inputted into the compilation processes. This essentially meant that they were able to backdoor a bunch of pieces of software that was produced by SolarWinds that were eventually pushed into different different pieces of infrastructure of, say, the U.S. government and like top 500 corporations in the United States. The very, very impressive thing is that it was essentially a very quiet piece of malware that was exfiltrating information. You could think of it as like essentially an act of espionage. The other interesting bit of it is that I don't think that today we know everybody that's affected. There's essentially three buckets, right? There's people that downloaded the thing and they don't know if they ran it. There's people who definitely ran it and they got their information stolen, and people that didn't touch the servers that had the malware that hopefully they weren't affected. But that's also what makes a software supply chain attack so insidious, is that a lot of the times you don't even know you got hacked, but you got hacked because everything looks like legitimate traffic. You downloaded an update and you put it on your system, and then you're suddenly running, like, I don't know, some intelligence agencies backdoor in the
Exactly. That's the problem, isn't it? It looks like it's signed by the right party, and it is. But what you don't know is that the key was abused.
Exactly.
Yeah. And I mean, these are two really famous attacks, right? And these are the ones that we know about because we're definitely looking. I want to say that we're looking at the nation state level, and we're sort of examining things very, very carefully. So we're discovering these things very fast. But there's a lot of this that probably goes on that doesn't make headlines at all because it's a bit lower level kind of attack, or corporate espionage kind of springs to mind as a this is a nice way to kind of go about that. So if that's kind of the problem, we frame the problem. I know that we have a bunch of tools available now. All of you are sort of participatory in the ecosystem of tools around solving this problem. Maybe we can just take a minute and talk about what are those tools. I mean, we've got InToto, we've got Tough, SigStore, and how do all those things kind of come together to help the average software engineer kind of go and solve this problem? We'll start with Asra because you didn't get much airtime during the attack portion.
Yeah, and I think actually I was gonna say, like, it kind of makes sense for me to maybe start with SigStore, and then thinking of that equation framework, I guess, that Santiago mentioned before, it'll kind of glue in with like the larger pieces when we start talking about InToto and Tough. So I think it kind of makes sense to start with SigStore. So SigStore is basically like a way to get developers. It's an open source tooling system, I guess, with lots of different components to get these developers in the open source to be signing their artifacts. Whether that's containers, whether that's binaries, really anything. And the way that it kind of works is it's a sort of modular set of tools that can be used in conjunction or can kind of be used as individual components. So whether that's you want to bring your own keys and sign your artifacts, whether that's you want to use the PKI system integrated into SigStore called Fulcio, which signs based on an authorized identity using the OIDC protocol. Which basically means you don't have to bring your own keys. You just have to bring some ID token, whether that's provided by GitHub, whether that's provided by Google, whether that's provided by Microsoft. So it kind of removes the whole BYO key situation. And then there's also another component along this, which is a transparency log, which maybe you're familiar with something like binary transparency or, this transparency log called Recore is essentially let's get all of our signature artifacts onto the transparency log so that we can verify that signing actually happened when it was supposed to. So it's a bunch of little tools that's kind of meant to be a sort of let's encrypt for software signing. The general idea is that you can kind of sign those polynomials of the equation going in. So maybe I'll pass it along to the tough side of things or in toto side of things, if one of you want to talk about gluing together components of this equation.
Sure, I could go next, and then Santiago could talk about how in toto fits in this nice picture that we have, right? We gave a talk recently. I'll try to bring up the metaphor again. Hopefully, I'm not abusing it too much. But if there's one thing you remember from this talk and you want to think about how to secure your own software supply chain, you can kind of think of it as trying to solve the vaccine problem. Supply chain, kind of same thing. I think it has a halo effect now, actually. But anyway, SigStore is kind of like the CDC. So if you're trying to distribute vaccines, SigStore is kind of like the CDC telling you it has an immutable registry, a permanent registry of how every single little vaccine was ever made, what lot number, expiration dates, and so on. And then now we're going to talk about Tough, which is the secure distribution side of it. You will use SigStore. You can use SigStore. There's many ways you can use SigStore. But one of the ways you can use SigStore is to record what we call the Tough timestamp. And it doesn't matter what it is. You can just kind of think of it as like the beginning of all the information about your software artifacts. Okay, and that will go into what your in toto, what your software supply chain looks like, and what keys you're supposed to use to trust them in the first place. And you do it in a way where even if hackers break in your system, you set it up so that they can't break the security system, the total security system at least. It's very hard. There's many bars for compromise. Anyway, so SigStore is kind of like the CDC telling you how every single little vaccine, the record of it. Tough is kind of like the FDA telling you why you should trust Pfizer or Moderna or J&J or Novavax or whoever is next. And then now Santiago can talk about how Pfizer or each of these vaccine makers can use in toto to sign their vaccines.
I was muted. So building upon, then we have this sort of a record of everything that happened, and that's why I think the name record for the transparency log is very apt. And then you have this sort of a way to distribute trust information, essentially who does what, so that then you know, I don't know, if you got a box that comes from Amazon, it says Amazon on it, and then you say, well, this is probably the package that I was expecting because I ordered, like, I don't know, a YubiKey. Then what you care next, once you know those things, you say, like, well, this comes from somebody I trust, and I know where to look for it. Then you care about how that came to be, right? So you would open the box, and then you would start looking for, hey, is my product sealed? Has it not been, like, crushed by boxes in transit, or going to the vaccine metaphors? Well, did they put it, like, keep it at an appropriate temperature so the vaccine still works, and so on and so forth. So to put it differently, the in-toto bits are going to give you some visibility of what was the process itself. What did everybody do? Did the developers write the code as they should have? Was this built in the right infrastructure? Was the right, like, tooling used to check for, like, I don't know, linting and static analysis and dynamic analysis? Was this fast? And all those things essentially will tell you whether you should really trust this. The analogy that I generally use is, for example, the pop-up seal on a bottle. And I think this is, even though this is a little bit closer to Tough, but if you get a bottle of juice and you are about to open it and you realize that the top of the bottle is, like, popped up, then you go, like, hold on a second, this is open. Like, somebody already opened my juice. And if you're a little paranoid, you go, like, I'm not going to use it. If you have the friends that I have, you probably won't drink this juice. So that's exactly what you're trying to get when you're using, like, Tough and in toto. You're trying to say, hey, was this opened and modified by anybody? And as Trishank was saying, like, from the developer all the way to me, nobody could have changed this in any way that they shouldn't have.
And I guess, like, the transparency log component of SigStore and the record keeping, as we call it, is kind of like you have that seal on the bottle of soda, and someone has, like, a trusted person has put on the log that they definitely put a seal on this, so you can go back and kind of check, yeah, all right, they put a seal on this. The seal's not broken. I can fully trust this.
Right. Yeah, it's like,
right,
you can publish in the New York Times, like, sorry, go ahead.
Yeah. Sorry, I just wanted to say we're doing this at Datadog now for the agent integrations. We're recording everything, kind of like in the New York Times, that everyone can look up for like all of eternity. So
Right. I like transparency logs compared to the New York Times because in theory that's the paper of record, right? You can put something there, just like suddenly all of Datadog releases are signed, and then like everybody must know, right? Um, and I think in a sense it's similar. You can put on record like I am now signing my releases, and you better expect them to be released signed.
with the New York
We
Times,
did.
maybe you
We did
should
have,
record there. Sorry.
sorry about that. A little bit of a delay here. We had a couple audience questions come in that I want to make sure that we answer. So the first is a really easy one. Where can folks go to get more information on the tooling? Like, is there a good one-stop shop to just go read up on the tools?
So
Yeah, all of these have like sort of different individual pieces. Sigstore.dev is a good place to start with Sigstore. The update
Some,
framework.io.
yeah, some folks are saying the update framework.io. Any other great links that we can just throw out?
Oh, definitely in toto.io, in toto.io. Unfortunately, there's
yeah,
no one place. Sorry, go ahead.
so I think in a sense a good community to talk through all of these things, maybe Sixstore itself, because and again all of these technologies have a lot of synergy with each other. So it's almost like we're wearing the three hats all the time. But it does appear to me that a lot of like exciting stuff is happening on the Sixstore side that could also weed into the Toto and Tough side of things. Um, but yeah, I think Trishank, you were going to say like, unfortunately, there's not a like one-stop shop for it, and that is true. I think that's like a big piece of innovation that's missing.
Yeah, I think we're working
Yeah,
kind of towards getting there as we start talking about like frameworks of software security levels. And in that sort of framework, I think there's recommendations for um, reference architectures around these specific toolings. And so I think things will kind of develop in the next couple of months, like as the CNCF has their own reference architecture being published right now, and these frameworks kind of start becoming more prevalent.
That's
So
that's a good.
no, go ahead. Sorry, latency.
I
Just
was
got the
just
best
going
of
to
me.
say that's a good segue into the next audience question, which is what's a good way to get buy-in for adopting these tools? And I guess like kind of the flip side of that would be do you consider the tools to be easy to implement, or are there challenges when you decide to invest in this level of security?
I could probably take this first, considering perhaps in total is like the higher bar. It did appear to me that after everybody got hacked last December, the attitude changed. So I see, for example, SolarWinds now has an amazing in total deployment that are using Tecton chains and they're like verifying for hermetic builds. If you want to look at like a good inspiration, do take a look at the Datadog integration. Overall, I think now there's a lot of tooling that should make it easier for you to deploy all of this like frameworks. Um, and at the same time, I think we're seeing a lot of like change in attitude from pretty much everybody in the space, realizing that this is now like a looming threat that it's being constantly exploited. I forgot if it was Sonatype. They released that supply chain attacks were up 600% this year, and that's on top of like 500% last year. That's on top of 400% the year before, and 73% on I think 2017 or 2016. It's just increasingly becoming the avenue of attacks, and I think just showing that statistics to your project manager and going like, or to your like CTO, just going like, hey, hold on a second. this is a big hole in my in our plan, so we need to address this soon.
Yeah, I just want to jump into, if you take a look at sigstore.dev and some of the blog posts, there's a lot of like sort of community involvement in setting up demos and setting up sort of reference GitHub actions that you can be using in your CI/CD systems to be signing artifacts. So that's probably another good place to start with, how do I just bare bones start signing my artifacts even without tough and key management, I guess. Using Sigstore's PKI system.
Well, there's
Yeah, I was
also
gonna
like an
say.
underlying. Sorry, just wanted to add that
No,
there's
go
an
ahead.
underlying like tough bits on it on the Sigstore PKI, so you kind of get that win.
Right. There's something called trusted delegations, I think, if I got the name right in the future. Yeah, but I think the idea, you do want to get quick wins in the beginning. You want to iterate over security. So one way to do it is maybe in the beginning you use Sigstore and Fulcio, and you don't even use your own keys, and you still get a very high level of security. Key management can be a bit of a pain, to be honest, but we're all working to try to make that easier, especially with things like Fulcio. You use throwaway keys. And then you can decide to upgrade to like hardware security modules in the cloud. You iterate. So you start with Sigstore, and then maybe you add Tough on top of that, and then you add Intoto on top of that. With Intoto, you can do things like something called attestations first. You don't say the rules of the supply chain, you just say what goes in and out. And I see many people doing that now. But you haven't solved the whole problem. You still got to specify your supply chain has to be immutable. Otherwise, you don't really check that Y equals FX. You need that part. So the idea is to iterate. And yeah. That's what I will say.
Yeah, and I think that's a really good summary of how folks can start small and get a lot of benefit almost immediately. This idea that you could use something like an OIDC token for something that we already all have because we're all logging into these platforms in order to sign artifacts. That's incredibly low friction and very, very cool. If we do want to go to the next level, though, of that, we have to, as you said, like kind of managing keys and stuff is a little bit of a challenge, and so we go through these things like key ceremonies and like how we establish different roots of trust. And I think as you sort of trend towards that side of the curve, you start to get some more benefit from the tooling, right?
Oh yeah, Asra can talk all about this one. She's designed an awesome key ceremony.
Yeah, TLDR, I guess Sigstore has its, so Sigstore has a tough root that is managing its web PKI public keys and the Recore public keys and, the artifact keys behind the cosigned CLI. So along with that, its root also, which is public on GitHub, does an automated update system as well, and also has the ability to now hold delegations where small to medium-sized open source projects can start using the benefits of Tough by becoming a Sigstore delegation. And in that process, it integrates with the Sigstore ecosystem of Tough. And you can say things like, hey, using the Sigstore ecosystem, I want to go verify a particular delegation's artifacts, and it kind of automatically grabs that Tough metadata, verifies it, and then uses those distributed public keys to do the verification for you. So it's kind of like this, clients don't have to, hold on to anything besides checking in on Sigstore's root and making sure that they trust it, which was initially created from like a live stream ceremony on Twitch. So one way to start trusting it is to go watch that live stream.
That's super, super cool. That I had not heard that story, that it started in a Twitch stream.
I think it was a cloud native TV. Yeah.
Mm-hmm.
Yeah, and it's sort of interesting as we look at all these different like signatories, for establishing roots of trust. We have all these competing standards as far as cryptography goes. We have like PGP, GPG, X509. Do you see these projects kind of bumping into any of the limits there in terms of what we can assert in certificates, or is what we have totally adequate?
That's a
I
good
could go
question,
into
and I
this
have a lot of
briefly.
opinions.
Sorry. Yeah, Santiago, you should go ahead. Hot takes. Hot takes first.
Okay, sorry. Yeah, so I think in a sense, all of this underlying mechanisms are very useful, and they are somewhat usable within the framework of, like, say, TOF in Toto 6 door. The problem that I see with them just using vanilla those things is that they were really never meant for this use case. I think as almost like a reactionarily like PGP, in that, like, a lot of people hate it, so I like it. But it is something that if you talk to open source developers, a lot of them, this is what they use. This is what they've been using for a while. But it is not used to, or shouldn't be used to, essentially talk about who's trusted to do what. But rather, is this person really who they claim to be? And that's when it gets a little tricky, right? You can say the same about X509. That's essentially meant to allow you to have this, like, highly hierarchical distribution of, like, DNS domains. And, like, when you start thinking about, like, binary transparency or, like, binary distribution, it just falls short. And especially when you start thinking about, like, what is releasing a thing, it is not like making a one-to-one connection to a web server, but it's actually saying, hey, this thing is meant for, like, longer time spans, that's meant to be used by people for many months, and this is probably, like, more high impact than, like, going to a website. So we need 2 or out of 5 people to vouch on this operation, and semantics of that nature that just really don't exist in X509. This doesn't mean that you can use those keys. For example, at least in Toto, and I'm almost confident that in TOF and 6 you can use PGP keys to sign your stuff. It just means that if you want to derive trust out of those keys, you probably want to take a look at the other meta information that comes with these frameworks.
Yeah,
Yeah, and,
absolutely right. Sorry. Go ahead.
Go ahead, Trishank.
Like Santiago is saying, PGP and X509 were not exactly designed to be compromise resilient, as we like to call it, right? PGP, the problem is it's really one key sitting there, and you lose it, that's it. The whole game is over. X509, at least you have a hierarchy of keys, but you still don't have things like threshold signatures, and there's a lot of rich semantics you can't necessarily. One of the biggest weaknesses with X509 is the same thing with TLS. Just because a root certificate vouched for you doesn't mean it was legit. Maybe they were compromised. So you have multiple roots of trust, and how do you know which ones to use when? So.
Yeah, and I was just going to add here. I think that with regard to this kind of idea of, like, what do we use to sign, we also have to think about kind of computational efficiency as well for verification, because you might verify this, at runtime, or you might verify this at random intervals. When you have a piece of software on a system, you might verify it at patch time. So sort of considering that as well as a means of, like, what's the trade-off here from a performance perspective?
Oh, Santiago should talk about this. He's done some numbers.
Trishank isn't lying. I did some numbers. The actual overhead of, like, technologies like this is pretty negligible compared to, like, an X509, like certificate check, say. This doesn't mean that we cannot do better, and I think it actually you can actually reach, like, very, very good performance by essentially doing checks on, like, checkpoints, and I think that's somewhat of what you can do, like, at the supply chain level. This will also let you, like, say, obscure some parts of your supply chain to consumers by saying, hey, I'm going to check this internally. I'm going to keep this as evidence, say that we need to audit this later. But here's another, like, shorter check that you can do to make sure that we are actually doing our due diligence internally. So yeah, overall, it is very low latency if you do things right, but there's also ways to do it like almost real time, like keep it on a service mesh or something like that. That I think that'll be the gold standard in the future.
So sort of change. Oh, sorry. There's a pretty good delay here, so I don't always know when you're jumping in. But let's go ahead and finish up this thought, and then I want to move on to a different topic.
Yeah, go ahead. I was just going to jump in like one final comment on the whole like X509. Yeah, the point that Trishank brought up about like the pitfall of that being, you have to trust your root CA anyway, and you can't really detect root CA compromise. It's kind of interesting in the Sigstore world where we are using X509, but we're using it alongside Tough and Recore, where our root CA is secured by Tough. And then our X509 certificates are all short-lived and stored on our transparency log. So there's like a couple mitigations that you can kind of do to like help out those X509 pitfalls. But yeah, again, like a lot of these, PGP, GPG, and X509 weren't really designed for exactly that, what we were saying before with key compromise.
So I think that I would agree with pretty much everything that you just said. Sort of changing gears, because we sort of related this back to the presidential executive order, right, which specifically calls out SBOMs in it. And I think that, one, I'm not the world's biggest fan of acronyms because we have too many of them in security, but I'd like to just spend a minute talking about this concept of SBOMs, or software bill of materials, as I prefer to say, and how they kind of relate to this entire ecosystem. So let's just start with Asra.
Okay, so software bill of materials, I guess, is like one way of sort of packaging up what you like got from your, like what goes into your software as kind of like an inventory or list of ingredients, I guess you could say. So it's kind of, like what you might see on a retroactive sort of, this is what went into it. These are the components. These are the ingredients. This is the CI/CD system. And one benefit of that is that it gives you transparency over your software supply chain as in like a global ecosystem. So where this kind of helps out definitely is what we were talking about right at the beginning, kind of circle back to some of the attacks we brought up, is sometimes you don't even know when you were like attacked. You don't know like the full, blast radius of a particular attack. SBOMs could probably help in this regard, where you kind of say, okay, I know I've been attacked. Let me go and do a, retroactive and postmortem on this, see where my blast radius actually ended up. Let's go check in on the SBOMs. And that will kind of, bring me back to exactly that component list and tell me, okay, this is the sort of effect of an attack. So I'll just start with that.
So I'll be the devil's advocate, and I think SBOMs are definitely needed. And the metaphor that I use for an SBOM is, say, like you buy an IKEA furniture or a Lego set, right? And inside of there, you essentially have a list of how many screws and how many like planks of wood you got, and all of the things that you needed to actually turn this box into like a couch. Now, this is very useful if you're trying to build a couch or use a couch, or know that you actually got everything you needed to make a couch, right? That's why there's a text in there that says, hey, if there's any missing piece, pick up the phone before you do anything and call us because we need to replace the box. Now, this is I would guess like the baseline for security in the software supply chain. If you don't have this, then you're in deep trouble. And I think that's why it's very, very good that we have this EO essentially pushing for this. Now, following on the IKEA metaphor, imagine that you open the box and all of the planks are there, but all of them have termites. Now, you have no way of knowing if you just bought like a termite couch or what exactly does this really mean. You know that it's probably wrong, but you don't know how they got there, who put them there. If you can just like shave them off and sit on the couch and say like, well, maybe they didn't need the whole thing. Maybe it's still like strong enough to hold me. And that's why you need stronger systems. You need something that tells you, hey, when I shipped this, there were no termites. And so it must have been on the truck, right? And with this information, you can start building a little bit better of a detective story of how things happen and why they happened and what are their implications, right? Because if it was, hey, I found termites on my couch, but it must have been on the basement. So like if I shaved them off, then probably they didn't do enough damage to my furniture. But if it was like, oh, the termites were there all the way in the warehouse, so like it's probably gone by now, then you can make different assessments. That's kind of what I'm trying to get at. I don't know if Trishank, do you want to add something?
No, I just wanted to, I'm going to steal this metaphor. It's brilliant. So,
Lots of good metaphors today. I feel like communicating why these things are important is probably like one of the tougher jobs. Like the technology here seems to be really accessible. It seems to be where it needs to be. We've got a lot of questions about selling it, and you've all done a fantastic job of sort of making analogies that are accessible to everyone, but also kind of taking a risk approach to how you're selling it to an organization. And I think depending on what you're making, like what kind of software you're making, it becomes increasingly more important to do this. But you could sell this to effectively anybody making software using these communications tools. So we kind of touched on the SBOM topic just now, and like why it's kind of important to the recent EO. Let's just talk a little bit more. We're just about out of time, but like let's just spend a minute talking about this one tool on the list that I wasn't familiar with before I started doing this panel, and that's Salsa. So where does Salsa kind of come into this?
I think
I'll
this
jump
is
in with
yours,
like a
Trishank.
quick.
Aren't you on the board?
yeah, but I would much rather have Asra talk about this.
I'll just start. Yeah, I'll give like a so one thing that I think it's important that it's framework for security levels for software supply chain artifacts. It's not necessarily like a here go adopt these tools. It's more of a framework to help you understand and suggest ways to mitigate each of the sort of attack vectors that could come along with your software supply chain. So I think like we said at the start, with these attacks, sometimes they're very difficult to sort of break down. And along with like what Santiago just said about like the benefit of SBOM being like, okay, you got to go and figure out what's going into the IKEA couch. But Salsa's main goal is to say, okay, here's a framework that you can use to sort of identify and what's the word for it? Systematically identify where your threats are in your software supply chain and say, okay, these are the sorts of things that I need to mitigate those threats. And so things like generating provenance, things like signing artifacts, all of those things go into mitigating things and giving you a higher Salsa level, but it is not like Salsa is like, the set of tools meant to do that. So Trishank, like, feel free to add in anything I missed.
Oh, no, I think you hit the nail on its head. Basically, Salsa slsa.dev, highly recommend everyone take it. Asra is absolutely right. So we to systematically think about how to start securing your supply chain, right? So Salsa level 1 is designed to be that almost everybody can get on board. We want this to be a democratic process, right? We want this to be easy for everybody, the small guys and the big guys. But it also has, it's basically a way to iterate your security. How do I get to level 1? How do I get to level 2? How do I get to level 3? And finally, level 4, if you really, really put the effort into it, right? And what security guarantees you get out of it exactly. So it has a lot of useful ideas, things like how to tighten, have things like reviewing source code should go without saying, how to tighten down your build environment. Very nice ideas in there, hermetic builds. Highly recommend everyone take a look at it. It's a way of telling your boss, look, how did I secure my supply chain? Here's a great number to it. So.
Right, and you could even say, hey, my budget, like we don't have a lot of budget for this, but can we please get on 1 or like level 0? And I think the nice thing is that you can use that also retroactively. You can say, hey, like we got this now, we can like tout or practice this to the broader world. Sorry, Andrew.
Oh, no worries. I was just going to say, I think that's a great place to wrap up. I linked the Salsa project in the chat for folks so that they have an idea of like where to go and sort of read up on this. We're just about out of time here. No more questions have come in. A lot of people have asked to see the cat that has been making cameos. This is my cat. The joys of working at home. But thanks again for being here with us today. Thanks for being a part of Datadog Dash and participating in our software supply chain roundtable. And we hope to see you here again at Dash next year.
Thanks so much, Andrew. I
It
really
was an
enjoyed
honor.
that.
Thank
It
you.
was a pleasure.